everyone, it's Mrs. Shannon, and we are getting ready to start Ecology Notes Part 2. Now, for this set of notes, there are going to be handouts for you to let you take the notes by filling in the blanks of the Cornell style. Feel free to use this. If you did not pick one up in class, you can print one off from the link in Canvas, or you can pick one up in class. If you don't have one, or if you are doing this at home and you're okay with it, you can go ahead and do your own handwritten Cornell notes, whatever works best for you. What I do want to make sure that you do, though, is answer the study questions at the end and write a 2 to 3 sentence summary at the bottom. Make sure you use complete sentences, please. And that's kind of to get the big idea of what this is all about. Now, in our first set of ecology notes, we talked a little bit about the difference between abiotic and biotic factors, those factors that are living and those that are not living without life. A means without. And we talked about the levels of organization. Now, we start at the individual level, and if we have individuals that can breed, that can reproduce together, then we have individuals in the same population. So if you're thinking about the classroom, for instance, and we have crickets in the back, the crickets can interbreed with one another. They're the same population, but they are a different population than the bearded dragon or than us, because we can't breed with crickets, obviously. So populations are members of organisms that can reproduce. Now, if you have more than one organism or more than one population in an area, you have a community. A community is different populations in an area. And so when we're talking about in an area, don't forget, it's kind of like a little grayish, like how big or small the area is. It could be within the scope of a log or in a heating vent. That could be your area you're talking about. Or it could be, in your bedroom. That could be the area that we're talking about. Or a football field, or the city of Elkhart, or the United States. And so we always kind of have to let people know when we're talking about an area exactly what that area is referring to. But communities are different populations in an area. So communities in the classroom for us would include populations of humans, populations of crickets, and a population of a bearded dragon. Now, if we were to start adding in the non-living components, the abiotic components, then that's when we're talking about the ecosystem. So when we're adding in the temperature of the room, the classroom, and we're adding in how much humidity is there, then we're looking at our ecosystem level. And the biosphere is just the bigger scale, the earth, all the living and non-living in the earth. Okay, so within any ecosystem, we need to talk a little bit about energy, and that's what the main point is in this set of slides. And so there are 2 laws of thermodynamics. Thermo means heat, and more specifically energy here. And dynamics means a little bit about them, how it works. And so there's 2 laws of thermodynamics. Energy cannot be created nor destroyed. Okay, you can't make it, you can't destroy it out of nothingness. But it can be transformed into different types. So if you have one form of energy, you can change it to a different type. You just can't destroy it. So we got to keep that in mind when we're looking at the ecosystem. Energy flows through the ecosystem. Okay, it cannot be recycled. It goes from one direction through another direction. And as it goes, we're going to find out that it changes to different forms. So when we're talking about energy flowing, it begins with the sun. All energy begins with the sun, solar energy. Keep that in mind when we're doing food webs later on, but we always begin with the sun, solar energy. At that point, we have producers. Producers are things like plants. They can take that sun energy. That energy from the sun is able to flow into the producer through a process called photosynthesis, which we'll talk about in a couple weeks. From there, the energy from the producers, such as the grass, can flow into the consumers when consumers like cows eat them. We call these first-level consumers herbivores. So a herbivore is a primary consumer. This one with a little line means primary. It's a primary consumer that eats a producer. Secondary consumers are carnivores. They don't eat the producers directly, but they eat something that eats a producer. And when I'm talking about eating, it's because that's how the energy flows from one organism to another through the process of eating and consuming. And then we have our tertiary consumers. Tertiary consumers can usually eat carnivores or herbivores. But along the way, from the sun to the producer and to each level of consumer here, some energy is lost as heat. And we'll do an activity to model that, okay? So not all the energy makes it from one spot to the next spot. Okay? So what are the different ways that organisms acquire energy? Well, we know that organisms can be producers, consumers, or decomposers. For the producers, these are organisms that produce their own food from the sun's energy through the process of photosynthesis. We also call them autotrophs. The auto means self, troph means feeders. So we have self-feeders. So producers and autotrophs, you'll want to know those two terms and know that they mean essentially the same thing. So most of the time when we're looking at producers and autotrophs, we're talking about plants. Sometimes we'll talk about bacteria, and there's other organisms called protists, but in our class, it's pretty much going to be plants that we encounter. Consumers are organisms that have to consume other organisms for their energy, and we call those heterotrophs. Hetero meaning other or different, and again, troph means feeder. So all animals are heterotrophs. They might be consuming plants, so they're herbivores. They might be consuming other heterotrophs, so they're carnivores. Maybe a little bit of both, omnivores, or what we call scavengers. Please use the prefix board when in doubt. A lot of our words are going to have the same prefixes and roots, and I try to keep those up on the board for you guys to refer to. And I know that hetero is up there for you to look at. Now, I just used this term. Oh, nope, I didn't use it. We'll use it up here. There's another term called decomposers. Decomposer is an organisms that consume dead organic matter for energy. So they're not consuming live things, they're consuming dead things, but they still need energy, and that's where they're getting it from. And so we have what's known as a saprotroph. It's detritus feeders, detritivores. Those are things that live on dead organic matter or detritus. So this is a fancy word for a decomposer. So notice that all of these, autotroph, heterotroph, saprotroph, they're just fancy words for producer, consumer, and decomposer. So what is a food chain? You probably did the food chains in middle school. A food chain just shows the transfer of energy from the sun to the producer, to the primary consumer, and then it goes on from there depending on how many organisms you're looking at. And notice that the arrow points in the direction that the energy is flowing into. Now, we also use a term called trophic levels. It's a feeding level. So producers will always be the first trophic level because they are going to be creating the food, so to speak, from the sun's energy. So they're going to be taking the sun's energy and putting it into a form that the other organisms will be able to consume and get their energy from. Again, that process is photosynthesis that will create that. So in this case, it says identify the primary consumer or the producer, which is our first trophic level, primary consumer, which is our second, all the way to quaternary. Well, here we go. We have our primary producers. This is our plants, our herbivores, carnivores, and you can see that it flows up in this direction. You can see the arrows are flowing up. That means the energy goes from this direction, from bottom to top. Another way, though, of showing the transfer of energy is through what's called an energy pyramid. Some of you may have seen this, some of you may not. So we have our food chains, and if we have more than one food chain, we call that a food web, but we can also use an energy pyramid. Energy pyramids show the amount of available energy for each trophic level. So the food chain and food web just shows the direction that the energy is traveling, but now we can actually look at that amount of energy available. So when we're looking at numbers, this is probably the way that we'll go. Now, when we're calculating the amount of energy that goes from one level to the next, we have to remember this, and this is one rule that you will need to know, is that only 10% of the available energy is transferred from one trophic level to the next. The rest is lost as heat, and it's kind of blurry here, but the rest is lost as heat. So when the sun's energy comes into the producers right here, you're going to notice that a lot of the energy comes up, but some of it is going to be lost as heat. And it says heat, but there's also like cellular processes going on. But either way, 10% of it's lost. Only 90%. Sorry, I just said that backward. 90% is lost. Most of it is lost. And I've been saying it backwards. 90% is lost. Almost all of it is either used up in cellular processes or lost as heat. Only 10% moves up. So if you have like 100, think of it as $100. You're giving $90 away and only $10 can move up to the next level. So if you have 1,000 units of energy, let me see if I can get this black bar off, 1,000 units of energy, and we usually use terms like units like calories or joules, but if we have 1,000 units that the producers are able to get in from the sun, when we look at the next level at all these grasshoppers that feed on the producers, they can only use 100 units of energy. Out of all of these plants, the 1,000 available, only 100 of the units can make it up to them. All the rest of it is lost to the ecosystem or to the organism itself through metabolism and heat. So from there, even though the frogs are going to be eating the grasshoppers or crickets here, looks more like a grasshopper, they will only get 10 units of energy. And the top one will only get 1 because 90% is lost. 90% of 1,000 is 900, so 900's lost, 100 makes it. 90's lost, only 10 make it up. 9 is lost, only 1 make it up. And so that's why you often have to eat, like you'll see consumers eating multiple organisms because they need to satisfy their energy needs. So here's the food web that I was showing you earlier. It's just interconnected food chains. They don't necessarily show the amount making it up to each trophic level, but they show the complexity of the feeding relationships. We can still see the direction the energy flows, and we can see more about how everything is interrelated. So for here, identify the producers, okay, which are the plants, primary consumers, which are like the mice that eat on them, the seed-eating birds. Any of the herbivores, remember, are primary consumers. Secondary consumers, spider that eats the insect right here, that would be a secondary. Another secondary would be like the hawk that eats the squirrel, that eats the grass. And then a tertiary. Tertiary, the hawk can also play a tertiary role because it eats the insectivorous birds, that eats the spider, that eats the herbivorous insects too. And so what I do is I usually tell people, start with the producers and then just follow the arrows. 1, 2. Now, if it can be multiple, like in the case of the fox and the hawk, just go with the highest level. So in this case, we have our 1, 2, 3, 4. They could actually be quaternary if we wanted them to be. So it gets a little fuzzy there. Usually we just need to be able to identify producers and primary consumers. So I hope this helps. When it comes to vocabulary, you need to know producers, consumers, autotrophs, heterotrophs, trophic levels, what a decomposer does. Let's see, what else do we need to know? Primary, secondary level consumers, herbivore, omnivore. You need to know the 10% rule without a doubt, and how to read a energy pyramid. So if you have any questions, let me know. I'll touch on a little bit in class. And it's the end for today.